Hello and welcome to this CATIA 2026x release presentation entitled What's New in AI-Powered Design. This presentation covers what's new and fundamentally changed in CATIA 3D Experience 2026x. Some of it is applicable for general CATIA and some just for the mechanical and shape engineer role, otherwise known as M3S. The presentation is Formula One themed, and some of the geometry I will be showing is showcasing McLaren Formula One. My name is Todd Wigglesworth. I'm based in Eastern Canada, just outside of Halifax, Nova Scotia, and I've been with GoEngineer for over 29 years, as well as with past organizations through acquisitions. My professional background is centered on CATIA with deep expertise in composites, surfacing, and electrical harness design. Additionally, I work with other tools such as Simulia for ModSim-driven analysis, including composite simulation, topology optimization, and lattice structure simulation. My contact information is in the bottom left of this slide, so feel free to reach out at any time. So here's what we're going to cover today. I'll start with a brief introduction and set the context for why CATIA 26x is important from both design and business standpoint. Then we'll move into what's new in 26x, focusing on core enhancements that improve productivity, usability, and performance for mechanical and shape design. After that, we'll spend a bit more time on AI-powered design and how AI is being practically applied. I'll also touch on what's coming next in an exciting new future direction for CATIA. And finally, I'll wrap up with a summary, key takeaways, and we'll leave some time for questions and answers at the end. Engineering excellence directly drives business performance, with design-focused companies growing nearly twice as fast as their competitors. Giving engineers the right tools empowers them to innovate and deliver high-quality products. Ultimately, innovation stands out as the key reason top companies win in their markets. Engineers need the ability to iterate designs as early and as often as possible in order to explore multiple concepts and converge on the best solution. The early stages of the product lifecycle offer the greatest flexibility for design changes. As that design progresses towards manufacturing, changes become significantly more disruptive and costly. At Dassault, they have something called the Studio of the Future. It allows engineers to imagine, create, and experience sustainable and delightful product experiences. So here's a teaser video to see in action how to win any competition and win the race.
Engines hum like a cosmic choir. Tires burn, the stakes climb higher. Monaco glows, a neon wire. Gen 7 speed, 3D dreams, chasing light through endless streams. Racing through the stars, the race is alive. Feel the thrill, the pulse, the drive. Stay ahead, eyes on the prize. 3D universe in line. Victory's yours, it's in your mind. Street lights flicker, a fast ballet. Twists and turns, no room to stray. The future's here, it starts today. The stars align, a digital chase. Universe bends in this night embrace. Your time is now, feel the race. Racing through the stars, the race is alive. Feel the thrill, the pulse, the drive. Stay ahead, a 3D universe defined. Victory's yours, it's in your mind. Your mind. You're mine. You're mine. The time is now. Feel the race.
The ultimate objective of generative experiences is to unify and extend all prior platform capabilities with the focus on three topics. Number one is the seamless integration with the virtual twin technology by enabling a continuous digital representation across the full product and system lifecycle. Number two is the alignment with Dassault Systèmes' sustainable world innovation by embedding in sustainability considerations directly into the design and engineering and decision-making process. And number three is expanded use of artificial intelligence by leveraging AI-driven capabilities to enhance generative design, simulation, optimization, and experience creation. This slide gives a high-level look at the Gen 7 strategy for design and engineering at Dassault Systèmes. It highlights the main innovation pillars: generative technologies, virtual companions, XR experiences, and core engineering fundamentals. The center section lists the key features delivered in Release 2026x, including major generative tools, new design experiences, and improvements like lightweight mode and command intelligence. Several items are still in beta, showing where Dassault is actively exploring new capabilities, and we'll talk more about what beta means on this presentation later on. The year 2026 column indicates that more enhancements are planned as these technologies continue to evolve throughout the year. So we've covered why early flexible design matters. So let's now look at what's new in CATIA 2026x, the core platform and workflow enhancements that improve speed, usability, and design quality. These updates set the foundation for other AI-powered capabilities that we'll cover in the next section. So the first enhancement I want to highlight is the new welcome panel or home screen. So when you search and retrieve data, those items will now be immediately available in what we call the Recents tab. So from here, you can open, explore, and get clearly visible thumbnails at all times. Also, bookmarks are going to be quickly accessible now, and you can navigate them without the needing to access a separate app or a web browser. You can even interact easily by dragging the bookmarks live into the CATIA product structure. Another interesting tab is what we call the What's New. This is going to highlight everything new from all releases of your apps and roles, so users can get up to speed on what the latest features are on GA or any of the FD packs or service packs along the way. We also have what's included a new content section where we can also add favorites for easy access. So we can create our most frequent items, enrich the welcome panel, and add favorites, such in this case where we add core material. Other tools include things such as the help documentation, getting support for the cloud, user communities, and also we have a direct link to e-learning available as well. CATIA 2026x also introduces a new progressive loading technology for accessing large 3D models on the 3D Experience platform. So the key features included in this are: number one, we have what's called instant visualization, so that the 3D content can appear immediately when opening a file without waiting for the entire model to load. The second thing we get is what's called view-dependent streaming, so that the data can load progressively based on current viewpoint as you navigate. And number three, we get smart memory management, so that according to what's visible, CATIA intelligently loads and unloads the data from the graphics memory card. This is a really exciting feature in 26x, and all this is going to help eliminate traditional wait times for large data sets, allowing users to start working with their 3D models immediately while the system optimizes and loads and unloads the data in the background. The concept of modules will enable flexible trade studies, and this option is now integrated into the M3S role instead of being in a specialized concept structure role. So it changes how large-scale geometry is created and managed. And I'm going to show a quick video on how modules can be used in new ways to organize your CATIA geometry. So think of them as like supercharged geometrical sets with named inputs and outputs.
Enhance your design flexibility using module technology. A module is a watertight container inside a 3D shape. He has his own positioning axis. Can be either a structure if it contains a child module or a design if it contains geometry inside. Modules are connected by interfaces using input and output. It can be contributing or not. The interfaces connect automatically using naming. We can also create alternatives of modules in order to explore different design. Making a variant contribute will disable all the other alternatives. When contributing modules are deleted, a module retains its interfaces and remains fully robust using fallbacks. It acts as dead geometry, serving as a reference for stability. Now, let's use it in a real use case. You can easily copy and paste your model from one part to another. At Paste Modules, reconnect using interfaces. Modules are compatible with libraries, allowing you to create templates. You can import alternatives, switch them on, and the modules will adapt accordingly. You can easily explore different design. Design with modules to ensure robustness and adaptability of your models.
So keep your eye open for the Modules tab down in the toolbar and all the new functionality you'll find in the M3S role. The 3D Experience platform also features an advanced visual programming language which requires no code. It's specifically designed for generating complex geometry and excels at creating intricate, repetitive patterns, such as tire tread designs, car dashboard dimples. If you have anything that would be challenging the model using traditional design methods, visual scripting is a great way to add robustness and parametric flexibility to your designs. It's generative shape design at an entirely new level. Here's another visual scripting quick demonstration, but of a Formula One project. So here the goal was to create a template of a simple button with many parameters to allow Formula One design teams to instantiate with many varying parameters. So from doing this template, you can add complexity quickly all over the steering wheel, as you can see here. So for visual scripting in 26x, they also completed a redesign of the user interface across the entire application. So first you'll notice a fully updated design for the graph nodes, featuring numerous enhancements aimed at simplifying the learning curve and increasing productivity. So for example, we've introduced some new color codes for the categories, provided direct access to integral node values, and added longer, more descriptive labels to help you better understand inputs and outputs. The second thing is that we've reworked the editor interface framework. This includes new panels, an improved stacking and docking system, and an updated toolbar that provides quicker access to key features, such as automatic node alignment. We also updated the library with a new dedicated section that groups all inputs and output nodes for easier discovery. And we took this opportunity to refine the settings panel by adding new categories and improving overall navigation and discoverability. One other major enhancement revolves around the user operator. It's an essential concept that enables individual customization and the creation of custom nodes. And we've added the ability to deep dive into user or data nodes. So with a single click, you can now access and edit the internal structure, modify parameters, or add new nodes. There's also one last thing, which is the breadcrumb navigation bar at the top. It allows you to easily return to the root level of your program. So let's talk a little bit about another new feature in 2026x under what we call an advanced operator. So we'll use this concept car to show off the capability to have a new feature, which is a G2 curvature continuity for the shape and edge fillet. So here we have a concept car and a grill and a new level of surface quality. And these two new operators are considered advanced and require an additional app to access them. You can see here we're changing the continuity to curvature. Then, as always, you have access to the main parameters panel to explore design variants or capture configurations for future reviews. Now let's spend some time on AI-powered design and how AI is being practically applied with CATIA to support engineers in everyday design and engineering tasks. So how does this look in context of Formula One? Well, if you're designing a high-performance race car, you're going to need to be able to do sophisticated engineering at breakneck speed. And so F1 teams and engineers never stop trying to rapidly evolve with their use of 3D Experience CATIA and the use of AI in helping to reduce design time. To accomplish this, Dassault has increased and embedded in 26x new AI technologies in three main areas: design, engineering, and experience. And today we'll focus on mainly what we call engineering. So please note though, before we begin, I need to clarify what controlled availability and beta means. So controlled availability, otherwise known as CA, refers to roles that are not fully mature. They could require R&D approval prior to use. And there's two types. There's CA commercial, which can be sold to customers, and CA no price, which is for evaluation only and cannot be sold. Beta refers to new features or commands that aren't yet integrated into a role. They're considered technology demonstrators and temporarily available for free for testing. So be aware, there's no support and the features can be removed or modified at any time. I've got a couple links here for detailed terms and conditions. You can click on the link or use a QR code to get to the correct page. I also want to make you aware that Dassault System, just like how they take their cloud security so seriously, they're also very transparent about their AI policies and have a web page dedicated to the topic. So if you want to learn more, just use the link or the QR code here on this page. Now let's talk about virtual companions. So within CATIA, from the top right bar, you now have access to what we call Aura, the first virtual companion delivered directly within CATIA. So with Aura, you can simply ask questions in natural language. So for example, you can ask, how do I design composite plies? And even if you don't have any prior knowledge on the topic, Aura will guide you step by step, explaining not what to do, but how to do it correctly. What's especially powerful is that Aura doesn't just give you an answer, it provides source material behind the explanation. And so that means you're directly connected to official CATIA documentation, allowing you to deep dive further, ensure you're following the correct and validated process. All of this is just available at your fingertips and directly in context with the design process. Going a little even further, companies can now integrate their own knowledge into the platform, whether it's PDF documents, guidelines, posts in 3D Swim. Any information can be in the system and available to Aura. So as a result, when engineers ask questions, they're not only guided by CATIA best practices, but their company-specific methods, processes, and standards. So exactly the way the organization intends. And again, this all happens in context directly within their design and engineering environment. And so for that example I showed there, we had the latest Formula One regulations in the environment, and designers and engineers were able to access and query those regulations instantly. They didn't have to leave CATIA, and the designs will remain compliant from the very beginning. Let's take a closer look at what we call Command Intelligence, which is a new AI-driven suggestion engine added to the M3S role. So in M3S, we have two new apps that we will be able to navigate. One is called Generative Shape Design Plus, or we call GSD Plus, and the other one is the Part Design Plus.
Stop searching. Start designing with Command Intelligence. For every selection, our AI predicts the best command to use based on best practices. It also helps to avoid sub-element selection and let you the choice to use them. The prediction refines with each new selection. With Command Intelligence, no more guesswork, no more searching. Its intelligence is based on 5 pillars. The first one is command prediction based on AI. The second one is smart command completion. The selected features are automatically filled in the command within the right subtype, streamlining your design process. The third pillar is smart selection. You are able to select both in the spec tree or in the 3D directly. At selection, the command will use the feature, but lets you the choice to use the brep instead. Your favorite behaviors command are also displayed and can be customized. With Command Intelligence, you create robust design. You ensure the ability of your model to handle variability and changes. Try it now.
Internal testing at Dassault has shown about a 20 to 30% productivity increase in surface and part design. So on the left, we have the traditional design process and user interactions from prior releases of CATIA. And on the right, we have the command intelligence workflow, saving up about 30% of the time. On this slide, I want to give you a sense of how command intelligence actually learns. So Dassault trains it on a huge collection of real mechanical design models, everything from Formula One front wings, body and white structures. Altogether, that adds up to tens of thousands of features the system studies and learns from. What it's doing, it's looking for patterns on how designers work, what commands they use, in what order across both concept and detail mechanical design. So when you're designing, Command Intelligence predicts the top 5 commands you're most likely to need next, as long as each one has a predictive score above 10%. That means fewer clicks, less hunting for tools, and a smoother overall workflow. Another new AI beta feature is called Generative Assembly. It uses an AI-based engine to analyze arbitrary parts and automatically identify mechanical interfaces, which here are highlighted as red, green, blue, and yellow surfaces on the components. These identified interfaces serve kind of 2 primary functions. Number 1 is they enable the automatic creation of engineering connections between parts. And number 2 is they establish semantic relationships that allow the assembly to essentially build itself. So here you're seeing the system intelligently recognize how components should connect and automatically generating the appropriate constraints and relationships without manual input. These mechanical interfaces can be used to drive things like generative tolerancing, which we'll cover on this next slide. So generative tolerancing, it's been around for a few years. However, you previously had to manually define the mechanical interfaces, like in the previous slide of generative assembly. Here, by clicking the automation button, the system generates both a datum and GD&T schema in a fully automated workflow. The first step uses AI to predict the appropriate schema structure based on your design parameters. And the second step automatically produces an ASME standard compliant GD&T layout that adheres to ASME Y14.5 standards, populating tolerance values and using default settings configured in your user preferences. Generative shape convergence is not specific to M3S, but more a ModSim capability. So in the past, part optimization could traditionally kind of follow 2 paths. The first one would be you would design the part geometry, you kind of run the FEA, change the part, rerun the FEA, and continue to repeat the process. Another option was to use generative design topology optimization, where you define a bounding box and load cases, and then the result is an organic mesh-based geometry that needs reconstruction or reverse engineering. Even back in the 25X release, we introduced this functionality within our generative design solution. It's the ability to optimize and tune parametric models based on load cases. So this feature enables users to work with CATIA parametric models and use a new gradient-based solver to execute an FEA simulation and perform sensitivity analysis to evaluate how the parametric modifications impact the structural performance under the various loading conditions. So you can set goals and then just let ModSim arrive at the optimal parametric part or assembly. And the significant advantage of this approach is that the output remains a fully parametric part, and it's going to be ready for direct manufacturing without requiring any post-analysis or reverse engineering reconstruction. So this smooth workflow is a major step towards efficiency and design consistency. So let's talk now about generative sketch constraints AI. In the past, users constrained sketches manually because the old auto constraints sometimes produce poor results. The new generative sketch constraints is based on an AI, was included back in 25x in all roles with Sketcher, and it auto solves an ISO constrained state where all sketch elements are locked. It uses an AI technology based on a graph neural network that learns from an extensive internal data set of industrial sketches designed using company know-how and technology standards. Generative sketch constraints has been improved even from 25x to 26x. Here we quickly can show you a side-by-side example of 25x on the left and 26 on the right. So on the left side, we use auto constrain in 25x, and on the right side, we show how it's improved in 26x to give better results. (26x) also introduced new options to the generative sketch constraints. Now users are allowed to delete constraints they may not like and then resolve again to get some different results. And the other option is if the users get into over-constrained situations, they can now heal to remove those over-constraints. Here's a new functional enhancement, and it's specific for visual scripting. It allows you to generate a 3D mesh from a 2D image or images using AI. So visual scripting automatically connects to an AI service, and after the mesh is generated, you can use traditional visual scripting operators to transform them into real geometries. So this is a beta feature, and it's currently limited on the cloud to 10 generations per day per user. And when you're in visual scripting, make sure you go into the preferences because you need to turn on the option to enable beta features in order to gain access. So the final topic of the day is all about the future of CATIA on the 3D Experience platform. And honestly, this is one of the things I'm generally excited about. So we've had some web apps before, but this is a big shift and a game changer. So CATIA and Dassault is making the CATIA portfolio available directly in a web browser. And so that means it's going to work on any device, Mac, Linux, pretty much anything with a modern web browser. So CATIA is actually going to be running as a SaaS service, but what you get is the same native CATIA experience you're used to. So when you're in generative shape design, part design, assembly design, which are all available, it looks and feels exactly the same, but it's in the web. So you can modify parts, update assemblies, run simulations. You do not have to relearn anything. It's the same CATIA, Simulia, Delmia experience you know today. The only difference is how you access it. So you'll open your web browser, log into the platform, and then you're directly inside of CATIA. So there's no installs, no media downloads, no fix packs to install, and no local setup or take up hard drive space. So if you're traveling and you don't have a workstation or a powerful laptop with you, you can just jump into CATIA and get real work done for wherever you are. And this has been released as controlled availability, and it will improve even more in the near future. So to recap on some of the topics we covered today. The Gen 7 strategy from Dassault touches on generative technologies, virtual companions, XR experiences, and core engineering fundamentals, and there were many features delivered back in 25x or earlier. In 2026x, Dassault introduced some major generative tools, new design experiences, and improvements like lightweight mode and command intelligence, some of which are still in beta. As this year of 2026 evolves, we'll see more improvements and new functionalities in FDs, which are functional deliveries, as they progress throughout the year and get released. Here's a chart with a few of the main roles available for CATIA in the 3D Experience platform as of 2026X and the main apps you get with them. Most of all the CATIA AI functions are available across all these roles with the exception of Command Intelligence, which is only available in the M3S Part Design Plus and Generative Shape Design Plus apps. I would like to thank you personally for your time today, and if you have any questions, feel free to reach out to me directly. And let's now turn it over to the Q&A session.
Hey everyone. Thanks for joining the webinar today. I'm just going to look at the Q&A questions here, see how many I can address, and go from there. If you have any other questions, just feel free to type them in and I'll try to answer what I can here. So there was a question about lightweight mode and how you access it. That was one of the new enhancements. And I'm not going to show CATIA today, but if you go under your preferences in 26X, you just do a search for lightweight, and you'll find an option that you need to turn on to enable that new lightweight mode. Once you do that, it will look just like you saw in the webinar video. You'll have everything kind of feathered out, and then you can load models in as you can. There's a question also about modules, if they're going to replace published geometry. So published geometries have been around for like ever in CATIA, even in the old CATIA v5. That's not going away. You can still use those to like create links between models, help make your engineering constraints more robust. But the modules functionality, it's new. So it's an extension beyond publications. It like handles geometry, rules, parameters. It can use the publications, and it should be used like the structure, top-down design on large models. Probably it's much more robust than using just publications themselves. There's a question about information populated into Aura. If I understand the question, I think in the video we showed like there was a Formula One rules or something that was in the platform. So basically, if you have anything such as a PDF, text documents, Word documents, anything that's saved into the 3D Experience platform on the PLM side, or attached as a document like in a bookmark, or something that was maybe put in a swim post that was published, those are all become text searchable. So then Aura will it will be able to search within those because they're in the system. So you don't have to load them into Aura or anything like that. They're just saved in the platform. It's a question about visual scripting. So yeah, visual scripting is something very interesting and new with CATIA. It's been around for a couple of years now. But you can probably the best place to go look for information on it is just there's a YouTube channel. So if you do a search, and I don't know how we can get this to you later, but if you just search for like CATIA visual scripting and X generative design on YouTube, there's actually a library of like samples as well as showing what the enhancements are at every release or FD releases. And it will give you some good examples of, where you may want to use visual scripting in the future. If you're doing any GSD work, anything with repetitive patterns, you have to look at visual scripting. It's much easier to use than just using regular CATIA surfacing commands. All right, we got more questions here. Prediction. So the prediction, probably the command intelligence prediction, is it history-based or populated or programmed? If that's with regards to the command intelligence, I think on one of the later slides, I showed that Dassault has like a library of industry-specific models. So like aerospace, automotive, that they populate. And then from there, they can understand what the picks would be based on the types of geometry are being created. But it also will in the cloud, it stores the prediction of what the users are typically doing as well. And that command intelligence is specific to the cloud only versions of CATIA because it's using AI at the Dassault cloud level. And I think I got to all the questions. And so with that, I'll end it here, and everyone have a good day, and feel free to reach out to me with any questions.